Hello, everyone. I think it's time. Thanks all for coming. Now, you all heard this morning, this room is only for the best talks of the conference. So no pressure there. Thanks, Jens. Well, regardless, hopefully it's the material that you're going to benefit from here. So from the title, we're going to talk about catch. I'll explain what that is in a moment. In particular, test-driven C++ with catch. Now, if you've not done TDD before, this is not going to be an introduction to TDD. So that's not what we're going to get out of this. We're going to sort of mention some of the specific technical issues with C++ to do with TDD and testing, just sort of in passing, really. Out of interest, how many people have done TDD or do TDD regularly? So quite a few, that's good. How many people here have not done any unit testing in C++? Anyone? No hands, that's good. It's a good start. All right. So what's catch? Well, catch is a unit or a test framework for C++ that I've written, and I'll come on to why I felt that I had to write it a little bit later. This is me, Phil Nash, my handle on Twitter. I'll mention this again at the end, so if you follow me now, you've still got a chance to unfollow me once you've heard what I've had to say. All right. So we're going to start right back at the beginning. So to get test frameworks for now, just a simple bit of code. Just a function to add two numbers together, two integers. Nothing too complex. It's so simple, you can just look at this code and just see, well, that's just going to work, isn't it? So would I write a test for this in practice? Maybe not, but it's a useful example. Now, if I do want to verify that this function does what I expect it to do, what's the simplest way that I could do that? Forget test frameworks for now. I mean, we could step through a debugger, but then we need an IDE, and that's all a bit heavyweight. What about just a simple assert statement? Simple C assert. Now, this is actually pretty good. We can just write a call to the function as we would in normal code, and we can use a normal C++ operator to compare it against a value that we expect it to come out with. We can write a few of these so we can get a good feel for it. There's no dependencies here other than the standard library. That's pretty good. What do we get if this fails? Oh, before I say that, there's a little bit more to it, actually. To make it a complete program, we do need, obviously, a function to put it in, maybe Maine, and we need to include the header for assert. So as I say, what do we get if this fails? So let's introduce a deliberate error. Use multiplication instead. Now, obviously, it depends on the platform. I got this from my installation of Xcode running Clang on my Mac, and it gave me this output. So it's told me what the line of code is that failed as I wrote it, and also where it failed. In this case, the function name, the file name, and the line number. So I ran this in Visual Studio on Windows as well. It gave me a very similar. I don't think it gave me the function name, so it does vary. This one also gives this very useful abort trap 6. I'm sure I couldn't do without that. So that's actually pretty good, considering we haven't introduced any extra dependencies. We've got some fairly good feedback there. It's all fairly simple, straightforward. I like this. So why don't we just do this? Well, there's a few things missing. First of all, it'd be really nice to know what this add 1, 2 actually evaluated to. That might give me some hints to what went wrong without even having to look at the code. Oftentimes, that's exactly what it does. It's really useful to get the breakdown of what these arguments are. And that's one thing the test frameworks will usually give you. In this case, although I got the name of the function, we can't guarantee that. So even if you write test names as functions, you won't always get that in there. It doesn't scale very well either. If you've got hundreds, maybe even thousands of test cases, this is not a very manageable way to do that. And so we resign ourselves to using test frameworks. It'd be a shame if in doing so, we lost all of those nice properties about this. The simplicity, the expressiveness, and the low overhead and low dependencies. So I'm obviously building up to something here. What does this look like if you do the same thing with catch? Actually very similar. We still have one include statement, this time for catch. Still need somewhere to put it. In this case, a test case. Now, I haven't named this. Usually you would. But you didn't have to in Catch. It will actually generate a test name for you if you don't provide one. It can be useful for demos. And instead of assert, we just say require. I would have used uppercase assert, but that's taken by Maiste framework. So I went for require. It's pretty good. Everything else is much the same. Still using natural syntax here. Use the is equal operator. So what else have we lost here? I mean, we've had to introduce an extra dependency. Well, we can't get away from that. But how bad is that? And what sort of feedback do we get from this? Well, to answer that, I think it's a good time for a little code demo. One more thing I forgot to mention. In exactly one source file, you do need to write this hash define before you include Catch. The reason is this will tell Catch to generate a version of Maine that will call your test cases. You can provide your own Maine and call into Catch that way, use a different define, but usually you'll do this. Just do it in one source file, and that's the only extra line over the assert example. So, about that demo. Let's see if I can get Yosemite to turn mirroring off. Okay. So I'm using a Mac, so I'm going to fire up Xcode. If you're not familiar with Xcode, don't worry. It's not going to be anything Xcode specific in this. It's going to create a new project. And I'll imaginatively call it Catch Test 1. Stick it on the desktop. Now, like any good IDE, Xcode generates a load of rubbish code for you. We just delete. So now this is real TDD. I've got a blank source file, and I'm going to include a file I don't even have yet. Let's bring Catch in, but we don't have Catch yet. It's not even installed on this machine. So that's obviously going to fail, if it does. So let's get Catch. Now at this point, I'm going to try and rely on the Wi-Fi. Let's see how this goes. I have a backup if this doesn't work. So this is just going to the page on GitHub where the single file, header file, includes all the Catch, is kept. This does usually come up after a few seconds. Okay. All right. You're just going to have to trust me that, that it is quite straightforward. Let's abandon that one. So I've got this one over here that I did prepare earlier. So let's put that into our project folder. So I'm going to put it just directly in with the other source files. Obviously, you can put it somewhere more central and shared if you prefer. This is just a simple way of doing it. That should now compile, but doesn't link because we don't have a main function. That's why I had to include that extra slide in. So if you remember, we just do catch config main, and now we have a complete running application, which I can run. Let's change that up a bit. Right, can everyone read the fonts here? I've tried to make them big enough to be seen at the back. Okay. So I've run that straight from within the IDE. Now I want to run it from the terminal as well, because we see a bit more there. So let's just get the path to the executable here. Fire up terminal. And there. A little bit of color as well. So very useful feedback. No tests run. That's because we haven't written any yet. So let's go back to the code. Now we can write some code. So let's do this Tdd style. So we'll start with the test. Again, I won't name it yet. And we're just going to require that when we call add, which we haven't written yet, with 1 and 2, we'll get 3. Of course, it doesn't compile. So we write add. Hopefully I get this right. In fact, I'm going to deliberately do this wrong, using that deliberate error, so that we can see what happens when it fails. Let's run it from the terminal. And here's the output we get. So just going through this, we've got the test name. We didn't write a test name, so Catch generated one for us. Every test has to be uniquely named so that you can uniquely identify them. If you've written a test name, that would appear here. Then we've got file and line number of the test case, file and line of the failing assertion, the assertion as we wrote it, and the breakdown of the expression. So this is interesting, because it's actually broken down that expression and given us the values of what add returned. We can see that it returned 2 and gives us a hint as to what went wrong. We haven't had to rearrange our assertion as we do in other test frameworks, where we'll say assert equals and then pass 2 arguments. We've just written a natural expression. So how does that work? Well, if we have time, we'll go into that a bit later. For now, it's magic. Just to finish up, so at the end we've got the summary. There's a lot of red here, a bit like a crime scene because everything failed. We can just see that one test case failed, one assertion failed. Okay, let's fix the test. Fix the code, sorry. Okay, run that now, and a reassuring shade of green. All tests pass. Nice little summary there as well. That's what we normally would see. So very minimal output when it succeeds. Okay, let's turn mirroring back off and back to the slides. Get that to work. Okay. All right. So I said I'd explain a bit about why I felt I needed to write catch. There's actually a page on Wikipedia dedicated to just listing C++ test frameworks. There's quite a few of them. This list isn't even complete. Actually, I captured this a couple of years ago. I know for a fact there's a few more on that list now, and that's not all of them. So why do we need another test framework? Well, I looked at all the others. All right, some of them. And I didn't like them. Or at least I didn't like certain things about them. You know, it's the usual thing. Didn't like that, so I write my own. But I was looking for some specific qualities in a test framework, which I'll go into a bit now. In fact, 3 values that actually I hold most of my code to. First of all, simplicity. Just want to use natural expressions without having to rearrange the way I write things. Minimum amount of ceremony. There's so much ceremony and noise involved in a lot of these test frameworks that just gets in the way when you just want to get in and get out. You should just be able to look at the code and see exactly what it's meant to do. So that leads naturally on to expressiveness. Expressiveness as a code. Again, I think don't underestimate the value of being able to write that code using natural expressions rather than having to rearrange it into an unnatural way. So those little speed bumps that can actually just change the way you think about how you code. But also in the feedback you get. So I've gone to some lengths to talk about the feedback. We need to get the right information back from the test to, as quickly as possible, get you into what went wrong, what do I need to do to fix it. We don't really want to get too bogged down by the mechanics of testing. And finally, I wanted a real low overhead. I tried out Google Test, was one of the ones that I tried a couple of years ago. It took me over an hour just to get it up and running on my Mac. And that was after having to change some of the source code. It was much too painful. I just wanted to be able to download something and immediately start using it. Hopefully I demonstrated, despite the Wi-Fi problems, that with catch, you do just that. You grab a single header file, include it, and you're done. So they're the values. That's why I ended up writing my own test framework. So let's go back to the code we were looking at earlier, this add function. Now I said that we don't have to name our test case, but we normally would. Now, this is interesting as well. Most other test frameworks force you to name your tests as a function or method name. And that's a bit of a problem because you can't use white space, you can't use any punctuation. Again, it makes it very unnatural. And on the one hand, we're told we should make your test case names as descriptive as possible. And that's really hard to do when you're forced to use this unnatural way of writing it. So with catch, you can just use natural free-form strings, just as you should do. Now you can be very descriptive in your test case names. And more than that, you can also supply what are called tags. So there's a second optional argument here. Anything you put in square brackets here is a tag. You can have as many as you like. You can now run test cases according to tags. So you can run everything tagged add or everything not tagged add and various combinations. You can actually get some quite complex test suites built up just using tags alone. So that's quite nice as well. There's actually a few special tags. Didn't have a slide for that one there, actually. Let's come back. I'll come on to that later. There's a few special tags that are built into catch. The most common one is hide, which will actually stop the test case from being run by default. When you run, as we did earlier from the terminal, with no arguments, it will run all non-hidden test cases. If you hide something, it won't run there, but you can still run it explicitly. We'll see an example of that a bit later. So let's take it up a notch. We looked at the very simple add function. Still simple, but now divide introduces floating points. Now, floating point comparisons could be a bit of a pain when you're testing. In this case, my vague grasp of floating point arithmetic suggests that when you divide 4 by 2, that does actually exactly divide into 2. But that's not always the case, and it's not always obvious when you're going to introduce rounding errors. So we need some sort of fuzzy comparison logic. And the way we do that in catch, we have this wrapper type, a prox, which just overloads all the comparison operators to give you that fuzzy comparison logic. You do actually have fine control over this. You can control the epsilon and scale, which I'll talk about in a moment. But by default, it gives you a fairly good, first approximation, I suppose. Just to give you another example, if we were to divide 22 by 7, that's very approximately pi. In fact, this is a bit too precise. So this will fail even though I'm using a prox because the precision is too high. So just to look at the output. Here again, we see the value now of it capturing what the divide function is returning. Well, we can see what went wrong, and we can see that it started to diverge after the second decimal place. So that's where we'll use the epsilon function on a prox. Here we're just saying use an epsilon of 2 decimal places. There's a scale you can also apply. It's very useful if you're working with very large or very small numbers. Just keeps things to a narrow window there. Now I know that catch is used in quite a few banks on trading systems and quant systems, including one that I maintain. And this comparison logic seems to have held up so far in those sort of very numeric environments. So I'm fairly confident in it. Okay. Now so far we've talked about simple functions. And oftentimes that's all you need. I would argue that we need more of that actually. Simple functions and functional programming help us to keep our code simpler, easier to reason about. But we do often still work with object-oriented databases, with mutable state, multiple state machines. So we do need to deal with setting up state. And when we're testing, we'll often need to go through multiple stages before we can write an assertion. And then we'll often have to repeat that in multiple tests. So most test frameworks have setup and teardown methods that can get called before and after your groups of tests, usually on a class. And catch does actually fully support that. But I haven't used that for years. The default catch way of doing things is slightly different. And I think it's a bit more of a natural fit for C++. So to show you what that is, I'm going to do another code demo. So let's pop out of here. Turn mirroring back on. Okay. So back into Xcode. Let's just reuse the same file, save a bit of time. So what I'm going to do is I'm going to imagine that I'm implementing a container somewhat like standard vector. Maybe it is standard vector. In fact, I'm just going to cheat and use standard vector itself, because we're focusing on the test here, not the implementation. So this is not really TDD. So what I actually want to test here is the relationship between size and capacity. And you'll see why this is a good example in a moment. So we'll start off with an empty vector. Now we would expect the size of this to be 0. No guarantees about the capacity. It's probably 0 as well, but because there's no requirement there, we're not going to require it. So let me start to add some things. Let's add a few values. There we go. And now, obviously, the size should be 3. But now we can say something about the capacity. Capacity is going to be at least 3. Maybe more. Probably is. We don't know exactly what it should be, just that it should be more than or equal to 3. That's actually not even possible in some test frameworks, because they don't provide the macro to do greater than or equal to. Some do. Again, in Catch, it's nice and natural. So we've got a problem here. We violated one of the guidelines of unit testing. Now, guidelines are there for a reason. If only we had Scott Mayers here to talk about that. The guideline is that we should have 1 assert per test. Now, this is often misinterpreted as being literally 1 assert, 1 assertion statement. But it actually means 1 logical assert. In this case, because we're talking about the relationship between size and capacity, those 2 requires at the end a 1 logical assertion. The problem is that we're also doing an assertion on the size at the beginning. It's in a different state. We've got 2 states, 2 sets of assertions in 1 test case. So we could solve this just by creating another test case, setting up another vector, and only pushing back the values in there. And that would actually be OK in this case. It's nice and simple. But we want to do more than this. We want to gradually build up and up. That's going to get quite unmanageable. So what we can do is we can put each logical assertion in its own section. That's now in its own section. We'll talk a bit more about good naming in a while. But it's sufficient for now. Let's make that a bit bigger. Okay. So we've got 2 sections to this now. You can think of these as 2 test cases in their own right, but they have some common setup. In this case, it's just declaring the vector. So nothing too spectacular. But what actually happens here, when we run this test case, it will run twice. The first time, it's going to execute down here, go into the first section, and execute that assertion. Then as it carries on and sees this section, it will skip over it and drop out the bottom. So I'm going to go back, start executing the test case again, get to this section, skip over it, and execute this one. So each section is executed effectively in isolation, as if they were their own test cases. As you can see, because we're using the stack for the shared state, it's a much more natural fit for the C++ way of doing things. Now it gets more interesting when we start to remove things from the vector. Let's do that now in another section. So you notice I'm going to embed this section within another one. Let's erase an item. So that's going to reduce the size, but not the capacity. That full screen. There we go. Okay. Just remove the first item. So a size of 2 and a capacity will still be greater than or equal to 3. It's still the most we can reason about it. Okay, well, wrong equals. Okay. And just to make it even more interesting, we'll do the same thing but with a pop back instead. We should have the same result. Okay, we'll run this in a moment, but let's just talk about what's happening here. Because we've now got 2 sections embedded within another section. It's starting to get a little bit more complicated. So again, let's look at what's happening. As we execute this section the first time, we'll come down here and execute all this. Come down to this section. Now this is the first time it's encountered a section at this level, so it's going to carry on into here and execute this. It will then skip over that section and drop out the bottom. Next time we come through, get to this section, skip over it, and go into this one instead. Now it sounds a little bit complicated when I'm explaining it that way, but actually once you get used to this, it's a very natural way of doing things. Each section is executed, each leaf section is executed exactly once, effectively in isolation. So let's run this and see what the output's like. All passed. Now if I run with -s, that will show me all the results even if they passed. So we can see just the last run through here. We can see the test case name, we didn't give it one, the first section name and the intersection name. Up here we can see that other intersection. And we can see our assertions. So there's quite a few test cases being run there from a bit of code that fits almost onto one screen even on this projector. So I don't know about you, but I think that's pretty effective. So let's come back out to the slides. Okay, right. And I'll talk a little bit more about feedback. I talked about it already, said how important that is, and some of the ways that Catch tries to do things a bit better. Let's just drill into that a little bit more. And I'm going to use an example from some other test framework. Most sort of XUnit-based test frameworks look more like this, assert equals in this case. And we're going to imagine that we're going to call a function called base 13 that just takes its digits and assumes that they are base 13 digits and returns the conversion, which is really just an awkward way of proving that 6 times 9 equals 42. Hopefully some of you get that reference. Now, if this fails, let's assume that you haven't actually written anything in base 13. Most of these other test frameworks will give you some output a bit like this. They'll assume that one of these values is the actual one, and one of them is the expected one, and just print out the values. So it does give you the breakdown, because we've had to rearrange the expression. But there's a few problems here. First of all, that's not what I expected. What was that one? I don't know about you, but when I work with these sort of test frameworks, I'm always forgetting which way around they're meant to be. Maybe I just don't use them enough. But I think that's a problem, because this could be really misleading. And I have been chasing down the wrong bug sometimes because of this. So yeah, actually it should be that way around. But even then, well, if you don't have the code available and you just see this in the output, it's not that useful. It's just not enough context there. We haven't got the original expression that we wrote to compare it against. So what all of these test frameworks do, and this is an example from JUnit, is they give you a place to put an extra string in there where you can write what it was that you were trying to do in the first place. Now, this can have its own merits. You can write things in a slightly different way there, so you can test out your own assumptions. But just to use it to overcome the shortcomings of the framework in the first place, I think is a bit of a shame. There's another example from another test framework. This is OC Unit, because Catch does actually work with Objective-C as well. And OC Unit is an Objective-C test framework. Very similar to the JUnit example, just with a string at the end. Compare that to the same thing in Catch. We didn't need to annotate it because it's capturing the expression itself. And there's the example, much as we saw earlier. Now, bear in mind that we don't need to say which was the actual and which is the expected, because we can see from here which is the left-hand side and which is the right-hand side. You can leave it up to you which one is which. Doesn't matter. You don't have to remember the ordering. Sometimes, though, still not quite enough. Sometimes you do still need a little bit more of an explanation as to what the context is. So for those cases, there's the info macro. Once you're into the macro, this works just like an O stream. You can use the insertion operator, different types there. And this will store up these messages until it comes to a failing assertion, and then it will print it out as part of the message. We won't print anything if it doesn't fail. If you do want something printed, even if the test succeeds, there's also a warn macro which works the same way, but will always print its message out. The another thing I found myself doing a lot was oftentimes that bit of context that I need is just the value of a variable. Maybe it's a loop variable or something. And if that variable is not captured in the assertion itself, so here it's part of a more complex expression, then I want the original variable's value. So I often write this little bit of boilerplate. It's not much, it's pretty simple, but I wrote it enough that it was irritating me, so I just wrapped it up with capture. And you can write loads of these things, and they'll just all be printed out along with your assertion when it fails, if it fails. Okay. Excuse me. Now, if you've done any BDD, you'll know that there's a particular way that we arrange test cases or specifications according to this given, when, then framework. And Catch now has built-in support for this, which actually builds on top of the section syntax that we've already looked at. So it doesn't actually add that much. And I want to give you a quick demo of that. Just by going back to the vector example we looked at previously. So coming back here, we start off with our test case. We didn't give it a name originally. We should do that now. But we should also change it to scenario. So in BDD terms, the test cases are scenarios. So what is it we're actually testing here? Well, we're testing that opacity increases with size, but doesn't decrease. Sure, we can come up with a better scenario name, but that will do for now. So the first part of given, when, then is given. And this is where we set up our state. So we do have to introduce a little bit more nesting. But I think you'll agree it's worth it. So given an empty vector, and here it is. So let's just indent all the things. So given an empty vector, well, we don't have a when here because we're not doing anything, so we'll go straight into then. We've already said empty vector. Then it has 0 size. Okay, that was easy. So given an empty vector, when values are added, then size increases, actually both size and capacity increase. Okay, so far so good. Given an empty vector, when values are added, and when a value is erased, then size decreases, but capacity does not. And then the final one, very similar, when a value is popped. Let's just cheat. Okay. I missed something. Did I miss? Have I got a missing brace somewhere? Ah, no, it's just Xcode. Okay. All right, so let's have a look at this. So all the givens, whens, thens, and whens, they're all just sections, same as before. It's really just an annotation thing. So as we go through this, we can say, well, we're in the scenario, capacity increases with the size but doesn't decrease. Given an empty vector, then it has zero size. Given an empty vector, when values are added, then both size and capacity increase. Given an empty vector, when values are added, and when a value is erased, then size decreases but capacity does not. That's starting to sound human readable, but it's also defining the structure of our code. And better still, when we run this with -s so we can see it all, we can see where the test name is. We've got our complete scenario description in a nicely formatted, human readable form. And that's true of all of these scenarios that we've just written. So I think quite a lot of bang for the buck there. Again, just over a screen full of code. And the given when then style has guided us through good naming style, I think. Okay, back to slides. Okay. So all the examples we looked at so far have been unit tests. And that's primarily what you'd use a framework like Hatch for. But it's not only for unit tests. Excuse me. There's a little bit of controversy over exactly what a unit test is anyway. I usually favour the Michael Feathers definition, which is a test that runs fast, first of all, and is deterministic. And secondarily, but still importantly, is fairly isolated, so that if a test fails, it will usually just fail in one place, and you can get to what's causing that failure very quickly. You know, the longer, more code you have to dive through, the less of a unit test it really is. There's not really a hard line there. So there's a whole category of things that are very similar to that maybe just involve a few more steps. We don't call unit tests, but we can still test very usefully using a framework like this. I usually call those integration tests. Again, there's not a hard and fast definition. I think most people agree that That's an integration test. Usually involves more objects, more collaborators, maybe touches the file system. I prefer not to access database or networking from an integration test. Leave that more at the system test level, but some people will incorporate that as well. So if you're using catch to test these things, it can be really useful to include unit tests and integration tests in the same test executable, but you want the unit test to run fast. So by default, I hide my integration tests using the hide tag that I mentioned earlier, and then I add another tag to say that it's an integration test. And that way, by default, when I just run my test executable, it runs all the unit tests and only the unit tests. But I can very easily run the integration test just by putting integration in square brackets on the command line like that. And on a build server, I'll always run integration tests separately. I also have some projects where I'll actually write performance tests using catch. Not necessarily the best use of it, but it seems to fit our project well. So we use the same principle, separating them out using separate tags. So this is the section where I wanted to talk about how we decompose that expression. Now, I've lost track of time. How am I doing for time? I think we've got time. So, going back to our original example, where we called the add function. There's a few components here. We've got the left-hand side part that we want to evaluate, get the value of, an operator, and then the right-hand side that we want to evaluate. So what we want to do is, working from this side, start to consume the expression by grabbing the right-hand side value, but stop at the operator. So we need something that's of higher precedence than all of the comparison operators. So let's have a look at a list of operators by precedence and see what we can use. So first of all, we said that it has to be left to right. So we can only go for the left to right associative operators. That rules this whole middle section out. Okay? Can't use scope resolution. Wouldn't be useful anyway. And we're going to need a binary operator because we're going to need both the left-hand side and right-hand side. So that rules out the unary operators. But we can't use the function call or array subscripting operators because when we grab the expression, we don't want anything trailing on the right-hand side. So that rules those out. Then we get down to pointer to member. It's binary operator. It's left to right. Doesn't have anything on the right-hand side. And it's higher precedence than the comparison operators. So that's what I decided to use. In fact, the arrow star operator specifically. We plug that in. We introduce this expression decomposer, which will create an object for us to start grabbing things. And then we have an overloaded arrow star operator, which will then consume the rest of it. I have to have this Boolean overload as well for some reason. Now you notice that what we're returning is the operand wrapped in this expression LHS type. The reason is because we need to do some more overloading yet. So this overloads all the comparison operators, just showing one here. And it also stores, fully typed, the left-hand side that we've grabbed. And the comparison operators also take the right-hand side. And so we pass all of this off into this helper function, capture expression, including the operator as a compile time constant. So that comes down to here. We've now got all of the components, and we can call this helper function, internal compare, which will actually perform the evaluation that we would have originally written, so we can tell whether it passed or not, sets this result type. But we also have the left-hand side and right-hand side independently in their original types that we're now converting to strings. We'll come back to that in a moment. And the operator, which we're now going to get the stringized version of. And that's how we decompose the expressions in catch. So if you're not familiar with expression templates or have done that sort of level of overloading before, that may have gone past a bit fast, but you don't need to understand how that works to use catch, of course. So I touched on toString there a moment ago. And this is the main way that catch will convert arbitrary types into strings. It's worth talking about this for a moment as well. In catch, we have a number of overloads of toString for a lot of the built-in types. We'll just do the right thing. If one of those overloads is not available, falls back to a base template, which calls onto string maker, which works much the same way, but we've had to introduce a class so we can do partial specializations, which you can't do on function templates. So we use this for things like standard vector. Now, if there's no specialization of string maker, it will then fall back to trying to see if there's a no-stream operator overload for it. Now, you'll see this in a lot of test frameworks. There's this really awkward way of trying to work out whether that overload exists at compile time so it can do something else. And catch is no different. It works about 99% of the time. Very frustrating when it doesn't work, but there's no complete solution. So if it determines there isn't an overload available, it just results to printing this string in the end. So if you see this in any of your test output, it's because you don't have any way for catch to convert it to a string. Simplest way is probably to write an O-stream operator overload. Or if you don't want to do that, write a toString overload. If you really have to, you can use string maker to do partial specialization as well. Now, I've devoted a slide to this because this is not actually documented yet. I've actually got a page up and ready to upload, but there's a few last-minute changes I need to make which may invalidate some of it, so I haven't put it up yet, but probably in the next week or so that should go up. Okay, now, I've done this talk a few times over the last couple of years, and I always finish on this slide, and it hasn't actually changed yet. I've still got the same things planned for the future, but I'm making a little bit of progress. First item, generators, has been something I've been working on for a while. This is a way of doing parameterized tests, maybe even property-based testing. It's actually quite an exciting area, but something that I really want to get right, so need the time to spend to work on it. But I've got a new implementation of it, which after I've finished this talk, I'm going to get back to working on. So hopefully that will be up soon as well. We also have a prototypical implementation of a matches library in catch. Does some basic string operations. If you don't know what matches are, have a look at something like Crest. But there's quite a few matches for different languages. Just a way of writing things that look like assertions, but can do more complex comparisons. I'm still undecided, actually, whether catch really needs its own matches library, or if it just needs to provide better support for incorporating third-party matcher libraries. So if you have any thoughts on that, do let me know. And finally, I mentioned a couple of times that catch supports Testdriven C. Reason for that is because I originally used it a lot for iOS development. What I don't have is an iOS runner, which means you can't run it on a device. And that's really a bit of a showstopper for most people doing iOS development. They need to run it on the device. I'm unsure at this point if I'll get to this, because now that Apple have introduced Swift, and that's the new direction that they're going in, I'm not sure how relevant this will be going forwards, but I may still get around to it. Again, if you have any thoughts on that, do let me know. And that really brings us to the end. So this is just where you can find catch and me. So catchlib.net just redirects to the GitHub page. So it just makes it a bit easier. My blog, where I often write about catch and other C++ and programming topics, levelofindirection.com. If that's too hard to remember, I also have extralevelofindirection.com that just redirects there. And of course, me on Twitter. Again, now's the time to unfollow me if you accidentally followed me at the start. And that's it, so thanks very much.
Yeah, are there some questions? Hi. As far as I understood, your sections are restarted. So when you matched the assertion in one, you continue with the next one, right?
Sorry, I was having trouble hearing you there.
Can you go back to your slides regarding the sections or the given when-then expressions?
I didn't have slides, actually. I've got code.
Or the code, yes.
I need to turn off mirroring, sorry. Okay, so this?
So as far as I understood, if the first condition does not match, then the other ones are not executed, right?
Sorry, the first one was what?
So if the first then does not match, so the assertion fails, then the others are not executed.
Ah, right, yes.
Because they depend on each other.
That's a good point. I meant to mention this as I went through. So that then, checking the size equals 0, that's going to execute in isolation. So it will go on to run the other whens. You may prefer to make that a dependent test, so that the whens are nested within that then, if that makes sense. In fact, probably easier just to do that here. So like that. So now when it hits that require, if the size is not equal to 0, it will just stop at that point, which is probably what you want in this case. I was just really using it to illustrate how you can have sections at the same level. Yeah, there's this idea of dependent tests. So certainly, once we've added the three values and checked the size and capacity are right there, well, if they're not, we don't want to go on and execute these next ones. So it's okay to have multiple assertions there. So does that answer your question?
Yes. And can catch help to parallelize this somehow? So when the first condition matches, then you have multiple independent subtests. Or?
So it was a question about parallelizing.
Parallelizing.
Yeah.
The independent
there's
tests that follow the first one.
Yeah, catch doesn't currently support that. So the primary focus is unit testing, where that shouldn't really be an issue. But I did say that we use catch for other things as well. There is a bit of a problem with concurrency and threading in general because of the use of singletons behind the scenes. Something I've been sort of working on over time to try and tease out a bit better. So it is something that hopefully we'll support in the future, but right now, not. So what I tend to do, in 1 or 2 times I've actually had to do this, do heavily multi-threaded tests. When I'm actually on the threads, I'll do my testing outside of catch, store the results somewhere, and then just assert on them when I've joined afterwards. A little bit more awkward, but you can do it. Okay, any more questions?
Yeah, here. Regarding this slide, can individual blocks be shared? For example, you copy and pasted one of the then blocks, I think. Can they be put?
I can't see who's talking, actually.
Here, sorry.
Oh, no, sorry.
The then clause, I think it was, you copy and pasted it. Could you also put that into a function and then just call it from somewhere else and it will still work, or do I actually have to copy and paste?
Yeah, you can call into functions. There's nothing passed into these tests, so there's no problem there. The one little gotcha when you're using helper functions and sections is you have to remember this rule about once it's seen a section once and completed it, it won't go into it again. So if you have a section within a function, and you have that function called multiple times, it might be surprising sometimes that you go into it and the second time it doesn't execute your section. So there's a little gotcha there, but you certainly can call into functions, and you call through whole layers of your code and come back again, maybe in a callback, and have an assertion there. I've seen that done as well.
Okay, and one last quick question. The generators you had on your to-do list, was that about data-driven tests, or what are generators? Okay, thanks.
Yeah,
so it's not there yet.
Generating multiple values.
Could you and would you write your tests in line with your other code in the same source files?
It's a good question, actually. Because I usually do write my code Tdd Style, if I'm writing brand new code, I'll usually start it in the same file as I was doing in these examples. Just because it's simple, you don't have to swap around files until it grows past a certain size. And then when I feel it's ready, then I'll put it into place and fix things up so that they work properly. Sometimes I'll start with it in its final destination to begin with. Just depends on my mood half the time. There's no right or wrong way to do that. There are some times where I've got some existing code and I'm thinking there's got no tests on it. And I'm thinking, oh, I really just need to write a new version of this. And that's a great example of when I'll write the code in line, because then I can have both of them coexisting until I'm ready to replace one with the other. But other than that, there's no particularly right or wrong way to do it.
Sometimes when doing test-driven development, it may be convenient to use a mocking framework. Is it possible to pick an existing mocking framework and use it with catch? And if not, what do you suggest to do? Yeah,
I get asked that a lot. And I've never really been that big on mocking in C++. I just don't find it's a particularly natural fit for at least the way I write code in C++. But a lot of people do find it useful, and they have been able to get other mocking frameworks to work with catch. And one of the things I've been meaning to do is to work with some of these people to just make it work a little bit nicer. I think Google Test and Google Mock. Google Mock you can use, but you have to effectively bring Google Test along with you, and that's a bit awkward. But some of the others, I think Hippo Mocks is a bit nicer. And there's a new mocking framework that someone I know from the ACCU has written recently. I'm not sure if it's gone live yet, but he also uses catch, so I know that it does work quite well. I don't have the name off the top of my head, though. Maybe I'll look it up. If you follow me on Twitter, you can ask me there.
More questions?
Hi. A few moments ago, you said about something about when you need to test something that is executed in a separate thread. So basically, you execute separate thread and store a value somewhere and then do an assertion. So is there some kind of support in the catch framework for asynchronous execution of the functions in general?
No. Well, catch is completely threading agnostic. Well, in that it doesn't know anything about threads. It's targeted at C++ 03. One of the things I meant to mention, actually. So it doesn't have any support for threading libraries out of the box. It doesn't know anything about them at all, because I didn't want to introduce any extra dependencies. Possibly in the future, I'll optionally include support for C++ 11 threading primitives. But as it stands, the best I'm going to be able to do is to make it workable with multiple threads by avoiding a lot of this use of singletons internally. So does that answer your question?
Yeah, more or less.
Okay.
Yeah, thanks.
Okay.
Hello. My question is, can these sections have tags as well? So basically, can I hide some part of it and later enable it or something like this?
Yeah, it's a good question. Currently, sections don't have tags. It is something I'm asked quite a lot. There is a bit of a problem in that we can't make sections work exactly the same way as test cases in terms of discovery as you're going through. Where the test cases are all eagerly registered up front using these static initializers. With sections, it discovers the sections as it's going through the code, so it has to have already executed the code up to a point before it can determine whether that section is needed or not. So if we allow tags in sections, and you say, right, run everything with this tag, well, it won't know that that section has it until it's executed a test case that doesn't have the tag. So it's a bit of an inconsistency, and it's something I've struggled with, but it's also something I get asked about enough that I may have to have a sort of a more compromised solution, particularly for things like the hide tag, because that could be quite useful. So not currently, but it's another thing that's sort of in the pipeline in some form. Okay.
If you have 100 of scenarios and one fails after it was initially successfully run, is there a possibility to isolatedly run this scenario?
Run the scenario?
No, I mean, you have code and you define several hundreds of scenarios. Mm-hmm. And after a while, you continue implementing and one of those scenarios fail. Is there a possibility in case of debugging sessions to run this scenario isolated?
So the scenario corresponds to a test case. They're basically the same thing. And at that level, you can specify an individual test case or scenario, or by tag as well. Okay. So you can do it that way. But if you're thinking of a particular branch through a scenario, so down to a given then, when, that has the same problem that I was just describing, that we can't specify individual sections to run, or individual given when thens to run. So partially, yes.
I'm also interested in a bigger test run. What's about your output formats, like HTML or XML, which you can, in the next step, feed to the toolchain and you get a different output? You know what I mean? You have to have a kind of report. Right, yeah. That's a good point. Actually, I should have covered that in one of the demos. So all of the output we've been looking at has been the console reporter. But there is a modular reporting system in Catch based on an interface. And there's 3 bundled reporters. As well as the console reporter, there's an XML reporter, which is a streaming reporter, so you can actually have something that's reading it as you go. And then there's a JUnit reporter, which uses the JUnit format that most build servers understand, which isn't a great format, to be honest. But I support it because it's so ubiquitous. There's actually a 4th one there now as well, which is more geared up towards when you're running within an IDE. It just gives you like single lines for each test case, which makes it a bit more useful in that case, called the compact reporter, which is a submission. You can extend with your own reporters as well. So if you wanted to write an HTML reporter, you could. And there was somebody who was suggesting writing a Team City reporter as well, which could be quite useful. So yes.
So one big advantage of Catch is that you can express your test cases quite naturally. What I've never liked so far when writing test cases was testing for exceptions. How do you handle those?
Right, yeah, okay. Well, there's a lot of other assertion macros in Catch that I haven't covered, just scratching the surface. There's a whole family around catching exceptions. We've got require throws as, and require no throw. Incidentally, there's also, as well as all the requires, there's check forms of every macro, which don't stop the test case if they fail. So you can have multiple checks all failing. So you've got check throws as, and so on. That's significant because you can actually check that something doesn't throw an exception, and if it does, it will still carry on. So you've got quite a bit of control over that as well.
More questions? How about the Windows support? So if I want to test things on Windows, what will I get?
Yes, all the examples I gave were running on my Mac. The question was about Windows. I actually use Catch daily on my day job on Visual Studio 2010 at the moment. Does run on 2013 as well. And there is someone who has done some work on integrating Catch with the 2013 test reporter, part of Microsoft's own test framework. So Catch's results will actually show up in the test panel. Another thing on my list, my long list of things to do, is to work with him a bit more on making that a bit nicer. But certainly out of the box, it runs, as we've been showing here, no problem at all, including all the colorized output in the console.
So basically the same questions. What are supported platforms? So you mentioned iOS, but what's about Android or Windows Phone? So it's limited to desktop, or? are mobile platforms target devices?
So I think the question was about cross-platform support
Exactly,
beyond Mac and Windows. So Macs and Windows are the platforms I use regularly. I know a lot of people that use Catch run on Linux, various flavors. Seems to run fine. Occasionally get bug reports and issues some people face that I have no idea about because I just don't use those platforms. The fact that they're quite rare is reassuring. It seems that most people are running just fine. It's usually the various different versions of GCC that cause problems, particularly older ones. But other than that, no, it's obviously running on the Mac, it's already running on a Unix-like system, and it's not doing anything terribly complicated, so it generally runs pretty well. There's also a maintained fork for Visual C++ 6, which you could consider cross-platform, I suppose, and some of the early ball and builders as well.
More questions?
Just one more point, actually. Someone was asking about exceptions, and I remembered another point there. You can also write your own exception handlers for non-standard exception-based exceptions. So you can catch them all in one place and translate them into your own message. So it has that support too. Okay.
Is there support for detecting memory leaks? In example, for in boost test, you get at the end a report of all the memory that was leaked.
Right.
That would be actually nice.
Yeah, there isn't built into Catch, partly because that's very platform dependent. My day job, again, what I've done is I've done the leak detection, which is only like half a screen long, and then I call. Have my own version of Maine, and I call into Catch programmatically, which I alluded to being able to do. That stuff, writing your own Maine, is documented. So, yeah, if you do that leak detection yourself, just using the Windows debugger library, it works pretty well.
Okay.